Hey guys, it's Miss Nelson. So this is the first video that I've done in the new space, so we're going to see how this works. But these notes are going to be over your properties of real numbers. Okay, that also includes order of operations. We've already covered order of operations in great detail, actually. And so the top piece of these notes are order of operations, and they kind of show you, in case you forget, the steps that you need to take, parentheses, exponents, multiply, divide, add, and subtract. If you go further down, okay, well, and actually order of operations all on the first page, excuse me. So if you go to the second page of your notes, we start seeing our properties, okay? Now, these are properties that we are going to use, especially with our equations and inequalities, because we have to know these properties in order to be able to solve for our variables whenever we are looking for them. So I'm briefly going to go over these. There's not going to be a lot to write. There's more of highlighting and understanding and things like that go with it. So if we look at our first property, it's the zero property of multiplication, and it states that any number multiplied by 0 is still 0. Okay, you guys know that. That's something that you learned a long time ago with your multiplication class, but it is in fact a property. Our second property is the identity property of addition or multiplication. It states that any number added to 0 or multiplied by 1 is equal back to its original number. Okay, so identity, if you see the picture here, it's a little girl looking in the mirror. So that means it's still going to be the same number. So if I add 0 to anything, I'm still going to have the same number that I had. If I multiply by 1, I'm still going to have the same number. So this is all about having the same answer. And that should actually be a 72 up there, guys, not 7. That's weird. Okay, if we scroll further, we have the inverse property of multiplication. Okay, and that states that any number multiplied by its inverse is equal to 1. So we have talked about this, that we talked about it, and I referred to it as its reciprocal. So remember, a reciprocal is a number just written in the opposite way of a fraction. So the reciprocal of 7 is 1 over 7. So when we multiply the two together, we get an answer of 1. The reciprocal of 3/4 is 4 over 3. When I multiply both of those, I would get 12 over 12, which again simplifies down to 1. Okay, so the inverse property of multiplication, inverse means the same as your reciprocal. Your commutative property of addition or multiplication states that no matter what order the add-ins or the factors, so the pieces you're using, appear, they both will equal the same sum or product. So what this means is, the best way I can tell you is you can move around within your community. Okay, so if you and your friend were standing side by side, you could switch places and the same thing is still going to occur. Okay, so it says John is talking to Susie. Susie is talking to John. They are both talking to one another. So it doesn't matter which order they come in because the answer is still going to remain the same. If you look at your examples, 5 plus 7 is the same thing as 7 plus 5. You still get 12 as an answer. 4 times 9 is the same as 9 times 4. You still get 36. Okay? So for our notes for this one, I'm going to say that you can move within the community. And it doesn't matter who comes first or second, you are still within your community. So therefore, you're still going to be able to do the same operations that you needed before. Your associative property of multiplication or addition states that no matter what grouping of the add-ins or products, they will both equal the same product. Okay, so commutative was the order. Associative is going to be the grouping. So you see in our examples that we have 4 plus 3 in parentheses plus 7, and it equals 4 plus, and then in parentheses 3 plus 7. Because it is all addition, I can group things differently and I'm still going to get the same answer. Same with multiplication. If I have 2 times and then the product of 6 times 3, it's the same as the product of 2 times 6 times 3. All of them equal 36. Again, because I'm only multiplying all together, I can multiply in whatever order and my answer is still going to be the same. So The easiest way I can explain associative property is that you can associate with whoever you want. So the groupings may move. Okay, groupings can move. Our last property is a distributive property, and this is a really important property because we're going to have to actually apply this property to simplify some products or some equations or expressions or inequalities that we get. And the distributive property states that multiplying a sum by a number gives the same result as multiplying each add-in by the number and then adding the products together. Okay, the number outside gets distributed to each number inside. So this can be a little bit confusing, so I'm going to show you what they mean. We have 5 times 3 plus 4. Okay, so normally what we would do per order of operations, okay, we would do the parentheses first. And I would say, okay, well, 3 plus 4 is 7, and then 7 times 5 is 35. Okay, so if I wrote that, it would have like 5 times 7 because I would simplify that. The problem with this is when we get our variables, okay? So if I have something like 5 times 4 plus x, I cannot add 4 and x together and then multiply the answer by 5. There is no way to do that. So there is a property, the distributive property, that says that if you take this outside number here and you multiply it by each and every piece that is inside the parentheses, and then we go back and we do the second operation that's inside the parentheses, you're going to get the same answer. This is extremely helpful when we have variables such as our x in this example. So I'm going to take this 5, and this 5 is going to say hello to this 4 by multiplying. So I'm really doing 5 times 4. I'm going to bring down that addition sign. Now, because the 5 said hello to the 4, think of it as going to a party. If somebody shows up at a party, they're not just going to walk in and say hello to one person. That would be considered rude. So they have to say hello to every single person at the party. So this 5 also has to come and say hello to the x. When 5 says hello to the x, remember anytime we have a number and a variable, we just push them together. So if I simplify this, I have 5 times 4 is 20 plus 5 times x would just be a 5x. This is where we would stop this problem. This would be the answer to this problem, which is 20 plus 5x, because we have two different terms.